Okay. Oh, I can't find the pen. Here we go. Let's start by reviewing what we were doing Friday, because that felt like a super long weekend. Let's. Who should we go with? Alyssa? Alyssa, let's go with you. There's a bunch of different questions I could ask from this. Is there anything you just want to tell me about it that you recognize by looking at it? Okay, so you're kind of trying to tell me how to do it? That works. I'll do that. I'll foil it. No, that's all right. What you remembered works. So you're basically just trying to do something, is what it sounds like. Nope, that's exactly what you're supposed to do. If you're looking at a problem and nothing stands out, then that's a good goal to have, is just to try to do something. Okay. Alyssa, do you want to call on somebody else to kind of tell me where to go from here? Okay. Okay, that is definitely true too. Original f of x was x squared. Good. Eric? Somebody else? Okay, Kelly? So I'm not giving any guidance on this. I just want you guys to tell me what you recognize out of this and anything. Okay, very good, very good. So this would be h, 2x plus h is cancel. Kelly? Somebody else? Okay. Perfect. So you put 0 in place of h now. Now we, oh geez, I said it, I didn't write it. Now we can put 0 in place of h, because originally it would have been divided by 0. So the answer would have been 2x. Excellent. Last person? Okay. Oh, okay. Oh, there's actually nothing else left to do. So that's okay. Do you go by Kenzie? Oh, I didn't know that. Okay. So I guess the last question we're going to get out of this is you could answer one of two things. What I circled in yellow and what I circled in green, what are they? Like, what did I even write down? So somebody said the original function was x squared, which was correct. What were we doing with x squared? Like, why did I even write it in this equation? Excellent. Nice. Correct. Correct. This whole thing was about finding the derivative. And honestly, I would have been okay, like, if you didn't use the word derivative, which is the correct word. So slope. So a lot of people remember slope, but they don't remember the word derivative or differential. I mean, that's great if you remember the correct term. And then our answer of 2x meant that the slope of x squared is 2 times the x value at that location. So it's important that we know what all of this represents. It's going to be really easy in calc to get so, how should I phrase it? You get so worried about the difficult work that's there that you dive in and try to learn a billion things about how to do these problems. And if you don't remember what the problems stand for, then they don't mean anything. So if you see what I circled in yellow, if you see that written down, you should recognize that as trying to find the derivative. And you could very possibly recognize that the equation it came from was x squared. Now, the answer obviously would be written differently. It wouldn't just have 2x. What it would say is it would say f prime of x, which I didn't write down to start with. It would say f prime of x. I'm just not good at talking and reading. F prime of x would be 2x. And anytime that I see f prime of x written down, that tells me that I'm finding the derivative or the slope of f of x. And whether this is a number or an equation just tells me about the slopes from f of x. So excellent. I mean, honestly, you guys remember a lot more than I expected you to, since you just learned it on Thursday and Friday. That's good. I will say, before we start today's, we have about half the class that hasn't even started the homework yet. And I need you to realize that we're going at a ridiculously fast pace. Our chapter test is Friday already. It's basically a unit a week. And if you're just going to procrastinate on homework, you're going to get lost really fast. So if you're one of the people that's procrastinating, do as much as you can today, because otherwise it gets really, really difficult if you're not caught up. And I mean, I'll gladly help you with whatever you want help with, but just know that it really hurts you if you procrastinate. So we are going to learn something called the power rule today, which makes your life, well, a billion times easier. And that, yeah, I mean, that is an exaggeration, clearly. So, some old peoples forever ago recognized patterns. So, somebody did the derivative of x squared, which we've done a couple times. Got an answer of 2x. Somebody did the derivative of x cubed and got 3x squared. Somebody did the derivative, and each one of these derivatives is that limit that we just did up, in the first example. So they take a long time. Somebody did the derivative of x to the fourth, 4x cubed. And they recognized the pattern that's here. And I would bet by me writing x to the fifth, some of you can already figure out the pattern as well. But a long time ago, nobody had really thought of trying to compare all these answers together to see a pattern. And once they noticed the pattern, then they had to go through the work of proving it, which we're not going to do. But then they noticed that it followed the same pattern all the time. If you take the derivative of a variable to a power, and it doesn't have to be a polynomial, doesn't have to be an integer. The power can actually be anything, decimal, fraction, whatever. If you take the derivative of a variable to a power, the answer is always going to be the power times the variable to the one less power. This is called the power rule. This you'll want to highlight, star, whatever in your notes, because it's a big deal. you no longer will have to do the limit to find a derivative. Now you'll be able to find derivatives practically just by looking at an equation and writing the answer. And I'm sure some of you already knew this, like I'm sure you learned from friends or siblings or whatever. So I'll go demonstrate it over here. So x cubed, the derivative of x cubed. Bring the 3 to the front, subtract 1 on the power, you get 3x squared. X to the 4th, bring the 4 to the front, subtract 1 from the power, you get 4x cubed. And so on. And up here, this starts to look slightly different just because the powers are smaller. Bring 2 to the front. When you subtract 1 to the power, you get x to the 1st. Now, there is one caveat over here. N cannot equal -1. Oh, I already... Wait. No, we're fine. I won't write that in. Go ahead, Peyton. Yeah, that's like in a couple of minutes. Yes. So, back in the day, I'll give you one of these, like, I'm old stories. So, when I took calculus, we actually did derivatives using limits for at least a month. And before my teacher actually showed us this power rule. And, it's supposedly, the reasoning for that is you're supposed to learn derivatives, what they represent better, etc. Well, AP doesn't believe in that philosophy. So AP actually pretty much just completely overlooks the limit version of derivatives. And you're only required to know how to use them. You don't ever have to do any derivatives with limits on the AP test. So we go straight into the power rule. You guys have basically been gifted a month of your life back that I didn't have. Does anybody have any questions on what's up here before we actually try to do some problems together? But this is where they discovered it from. Somebody just basically noticed patterns, followed them. Okay, well then let's demonstrate and practice it on some examples. I'll try to set up notes a little different today. I'll try to label them like your Khan Academy homework, see if that helps. You guys basically just let me know if something that I'm doing in notes that you like or don't like. This is the first year I've ever not used the textbook, so I'm learning as I go on the best way to set it up. Okay, so the power rule works on any power. And it definitely does not matter how it's set up. So x to the -3. Let me write down x to the 2/3. X to the -5/2. Okay? Actually, I should put some space. Oh, that's a lot of space. Okay, and then you'll definitely get used to my notation after a little bit. If I write dx in front of something, that's kind of like a verb to say take the derivative. Okay, so taking the derivative of a negative power works the same. Whatever number is here, put in the front. And then you subtract 1 from the power. Now, I'm going to write it in here. You definitely don't have to write that. So, we've got -4. By far, some of the most errors that I'll run into is you guys will accidentally go the wrong way when you're subtracting on negative powers, or fractions, things like that. That's honestly where I see most of the errors. Okay, if I take the derivative of x to the 2/3, I'm going to put 2/3 in the front, x, and then I'm going to subtract 1 from 2/3, which would give me negative 1/3. You can definitely write the answer like that. I will tell you, you're probably not going to see this answer in Khan Academy because they do a lot of multiple choice. The math correct way of writing this answer would be 2 over 3 cube root x. I'll write a little note there if you guys need a reminder. Negative on the power means downstairs in the denominator. The top number is a power. The bottom number is a root. So I don't know if you needed those reminders, from past, but so this one, the negative means to move it to the bottom. The 3 means it's cube root. Why don't you guys see if you can take the derivative of that third one? I actually have no idea who went last. Was it Haley? Kenzie. That's right. Kenzie, who's going to do us the honor? Okay. That was very nice of you to ask. Okay, so you go by Bella, not Isabel. What did you do, or were you able to get this one okay? Okay, what'd you get? Oh, you're giving me the simplified answer? Okay. Unless you meant, you could also write, this is what's annoying about roots. 5th? No, 7th. You're right. So I don't know if you meant the bottom one or this one. Your work that you may have done in your head or just written down would have been negative 5/2 x, and then when you subtract 1, it's negative 7/2, which was correct. Both of these answers on the bottom are all correct. To be honest, all 3 of these answers that I'm writing down are all correct. It's what's annoying about math. It's what's nice and annoying. There's multiple ways to do things. There's multiple ways to write them. Good and bad. Multiple choice, it's usually a bad thing because then you have to recognize which one is which. Free response question. You could list any of these 3 answers to be correct. Okay, how did this go? Does somebody want me to answer questions on anything, like any way the answers are written, whatever? Okay, then I'll keep going. The next section is still power rule. We're basically just kind of making it a little bit more complicated as we go. So power rule, needing to rewrite first. I wrote down 6 examples. And I purposely tried to choose examples that have common mistakes. So I'm trying to maximize our time. And if you can't read something, let me know and I will clarify to write it better. Okay, these are the 6 we're going to do. If you feel like you know how to just do them already, you can certainly try them. Otherwise, I think what would work best is if we rewrite them together, and then you guys try to find all 6 derivatives, and then simplify the answers. Okay, first one. First one should be rewritten. I didn't tell you how to do the... I wonder if I should take out the 3 and the 5 and the 2. We'll leave it. We'll learn on the go. You're going to rewrite this as 3x to the negative 2. Because it has to be written as a variable to power up on the numerator. B is going to be rewritten as 1/5 x to the negative 3. The 5 does not come to the top. C is going to be rewritten as x to the 1/2. That's going to be by far the most common one you run into. D is going to be rewritten as x to the 5/3. E, I didn't leave enough room for E. E is going to be 5x to the negative 2/3? No, negative 3/2. And F is going to be 2/3 x to the negative 1/4. Okay, let me do the first one with you just to make sure you know how to do it with a multiplier in the front. So when you do the power rule and you bring the number down in the front, you're just going to multiply it by a number if there's a number there. So this negative 2 does come down to the front, but it will just turn into negative 6x, and then you subtract 1. So if there's a multiplier in the front, you just multiply the power times the multiplier. Okay, why don't you guys see if you can do these other 5? Oh, and I can't believe I should have admonished myself for my notation. I did not write the derivative notation anywhere. Maybe I'll just write f prime in the front. Bad notation, but I'm going with it. Let's see. You don't have to answer yet, but I'll just kind of... David, let's put you in charge of B. Jack, you'll be in charge of C. Julia, D. Caden, E. Lila, F. So whenever you guys are ready, you can certainly. Perfect. Perfect. And I will write it differently. Both answers would be correct. Negative 3 over 5x to the fourth. That would be a multiple choice version. First one I didn't write would also be negative 6 over x cubed. So they're both correct. One is just like mathematically correct notation. It certainly would. Did you figure out how to write it in Simplify? Okay. So it would be 1 over 2 square root of x. No, good. Very good. I'll certainly kind of... Oh, you're ready. You're already ready. Okay. D. Like that. I wonder if you were just writing really fast. It's supposed to be 5/3 x to the 2/3. And I wonder if you just didn't see it or you wrote too fast. Yeah. No, that's fine. That's why I thought you were trying to give me a different style answer or something. This was good. Okay. Nice job. E. I don't know. Oh, Lila. Okay. You're in charge of E. Wait. Okay, wait. So it's negative 1/6 x to the what? Okay. Let's go through this. Where did the negative 1/6 come from? Oh, you're doing F. Okay. I feel a lot better about that. I thought you were on E. Okay, so you said negative 1/6 x to the, what'd you say? Negative. Okay. Yeah, that actually looks a lot better. Good, because E, I was wondering where on earth you got numbers from. Okay, so negative 1/4 times 2/3. You guys are certainly welcome to do scratch work somewhere else or off on the side. So, yes, negative 2 over 12 is negative 1/6. Good. And if we wanted to rewrite this, we could write it as negative 1 over 6/4 root of x to the 5th. Very good. Who had E? Caden? That may be right. Try not to mix decimals and fractions if you can. So the negative 15 halves. Negative 15 halves x to the, I think you said negative 5 halves. Yes. Yeah, you said negative 7.5, yeah. So then this one rewritten would be negative 15 on the top. 2 square root x to the 5th. Basically, the reason you're not supposed to use decimals, if you can help it, is writing a decimal within a fraction is considered not proper form. It's not wrong. It's like mathematically awkward. Okay, there's a lot of stuff up on the screen right now. I don't know if you guys have had time to digest your work or your answers. Is there something somebody wants me to go over? Maybe I wrote something up there and you don't get why. I like it with a root instead. So if I did a root, it would be cube root of x squared. And you know, now that you say that, textbooks are kind of weird on this, where sometimes they feel like a fraction power is like better. But it seems like whenever they put it in a denominator, a root is considered better. And I don't know the reasoning or, whatever. So I don't care whenever you guys write one or the other. But yes, the fraction powers can switch frequently. Do you guys, should we just move on? Or, because otherwise I'd be happy to answer any other questions. We're actually going really fast today. Okay. I didn't catch that. It was chopping in and out. I heard fraction simplified version was all I got. Maybe somebody else could say it, or when do you have to? Is that what you're kind of asking? Oh, gotcha. The answer is you don't ever have to. So the reason I'm going over more than one correct answer for each one of these is this is usually the hardest algebra part of calc for most people. When we get to the end of the year and we're taking the AP test, the AP test is in two parts for calc. Multiple choice for 45 questions, free response for 6 questions, but like big 6 questions. So they're equal time. On multiple choice questions, the answer that would be written in multiple choice would always be this proper form. And so that's why I usually try to cover this. Because if I don't cover this, what happens is a lot of you learn how to get the answer, like say the first one written. So if you figure out this answer, then you might get thrown off trying to find the correct answer in multiple choice. So I'm only giving those math correct answers for multiple choice answers, like for you to be able to pick a multiple choice answer. On my tests, if it's free response, you're allowed to write whichever answer you want. So like the ones that have starred in yellow that are simpler, I shouldn't say simpler. The ones that are starred in yellow are less work. Those are fully acceptable. I'm not a fan of trying to change the answer to look different just because to me that's just adding more unnecessary steps to make errors. I'm always a fan of doing as little steps as possible because that's basically how you make less errors. On multiple choice, it's just right or wrong. If it's free response on the AP test, they absolutely will accept any version. They will not take points off if your answer is in a different form. It's just multiple choice. It's like if you answer negative 6x to the negative third, that's just not going to be a choice for multiple choice. So you'd have to know that it represents this one instead. That's all. I'm sorry if that's confusing. I just want you guys to recognize that there are multiple ways to write the answers. I get it. It makes it feel unnecessarily hard. Great. Okay. Then let's do the last part, which is derivative rules, which we kind of already covered one of them. And if this makes you feel better, do know that tomorrow, we've already covered part of tomorrow. So tomorrow we're going to have a very small day, and that will allow a lot of you to catch up if you need to. Just giving you a heads up. I know I mentioned it before. So our test is supposed to be this Friday, our unit test. Just because, in my opinion, the school board did a terrible job of setting up the calendar and really killing AP classes. So we have, the test is supposed to be Friday, but they've also now canceled school Friday because we start distance learning on Monday. But I don't have an extra day to give you. So what I'm kind of doing is Thursday I'll finish up teaching anything from Unit 2. And I'll give you guys the outline, I don't know, Tuesday or Wednesday or something, I don't know, ahead of time. I'll cover anything from the outline that you want covered on Thursday. And Friday, I can unofficially be on Google Meet. So if anybody wants help with anything, I can help you guys. Like I don't know if I have to do it during lunch hours. I don't know how that works. I'll find out. So we don't have school Friday, but I'll be on to help you guys. And then you need to take the test before Monday, or something like that. That's kind of the fairest way I thought I could set it up. Not that it's a great setup, but otherwise what's going to happen is you guys are just going to have way too much work on individual days, and I don't want to do that. So that's this week. So just basically kind of be prepared. So basic derivative, I forgot to write this, properties. I kind of feel like one of those mad scientists today where I'm trying to think of too many things at once. Okay, so first, basic derivative property. If you take the derivative of a constant, like 5, what would be the derivative of 5? Which seems strange, but... Ola, what would y equals 5 look like? If I graphed y equals 5. Yep, 5 high, flat, like horizontal. What would be the slope of this line? Because that's what derivative means. Perfect. So that's our first property. If you take the derivative of a regular number, it's 0. Excellent job. You're going to find that the simplest derivatives are actually harder than the more complicated ones, because like doing the power rule on harder ones is easier. So think of this as like slope-intercept form. So if you have the equation 4x, the slope of 4x would be 4, because that's mx plus b. So derivative of kx would be k. And the only reason I'm emphasizing slopes repeatedly is because that's what a derivative means. Okay, and then the last two are that if you add or subtract multiple things, you can do the derivatives separately. So, like if I were trying to take the derivative of x squared minus 4x plus 3, I could do the derivative of each term individually in my head. That's basically what this property is for. It's for doing things in your head. God dang it. And then the last property we have basically talked about. It's if you have a multiplier. So like when we had a multiplier of 3 in the front, that doesn't affect you doing the derivative of the variable. I don't care how you want to write this in your notes. I need you guys to get that you cannot take the derivative of division or multiplication separately. And this is by far the most common error, doing derivatives with properties. Because you guys are so used to when we did limits that you could just kind of like do everything separately, individually, that it seems like you should be able to for derivatives, but you cannot. So we have to learn special ways to do derivatives of division and multiplication. I say spoilers because that's going to be called quotient rule and product rule. Okay. And then I just took a screenshot of a question directly out of Khan Academy, because one of the methods on the AP test is to apply properties to tables. Come on, click. There we go. So this is actually a pretty common AP multiple choice question. And that's the sole reason it's part of Khan Academy's question banks. So I'll give you a minute to write this one down because I'm sure it's whatever you need to. Ooh, good news, my phone just told me my computer desk and chair are 10 stops away. I can finally take my computer off of my kitchen table for 8 weeks. Okay, so I'm sure a handful of you have it written down somewhat. First thing I'm going to do is I'm going to separate each of these derivatives. So I'm going to do the derivative of f of x minus 3 times the derivative of h of x plus the derivative of 1. And at x equals -1, it just basically is the table. So the derivative of f of x at 1, -1, would be f prime of -1, which according to that table is -3. H prime of -1 is also -3. That's stupid. Why did I did not notice that. I wish I would change that number. Now you have to know which one comes from what. I don't like when they repeat things, so that if you're trying to determine what came from what. And then the derivative of a constant is 0. So then our answer would be -3 plus 9, or 6. The table ones are ridiculously easy if you know what to look for. They can look really confusing if you're not sure on notation. Notation is usually the biggest thing on table questions. Okay. I mean, like, it feels weird to say that this was a short day when we went 46 minutes. But I got everything in. I didn't know if I was going to do that. So I'm done there with new stuff. Go ahead, Katie. Right here. In the problem, it asks you to find the derivative. So the notation d dx means to take the derivative. It's like a verb. Well, it's always going to ask for the derivative. As we get to more complicated problems, you start needing original and derivative things later. So basically any question that somebody asks me, is it always going to be this way? No, because Calc is weird, and that basically has loopholes for pretty much anything. So you're pretty much all year long, you're going to be asked to do one of three things. Take the limit, take the derivative, take the integral. So Isabella, d dx is usually the notation that's used if it's not a function. So if it starts off by saying f of x equals, you write f prime if you're trying to write the derivative. So f prime of x is almost like a adjective where it describes the equation. D dx is like a verb telling you to take the derivative. So they both, f prime means it is the derivative. D dx is notation saying you're taking it. So they kind of say the same thing, but it's just different parts or different uses. And I'm going to be pretty lenient on notation with you guys. It takes a little while to get the hang of all the notation. All right. Well, I'll be on here until 11:15. If you guys want me to help you with anything, or if you have questions from your test, whatever. If you just want to work on your homework for the next 25 minutes, you can do that. And then, like, if you get stuck on something, you can share your screen with me, and I can just help you through it. I mean, that usually works pretty good, too. So you guys kind of pick and choose whatever you need to work on. If you are behind in the homework, and I don't like calling out people individually, so I'm not going to, get caught up, please. I mean, it feels weird to have to send emails home to your parents when you're behind. You guys are pretty much should be close to self-sufficient by now. So either way, I'll be here to help you guys out with whatever you want to help.